Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, the atomic structure. Today we will begin with lecture 8 from the course, but make sure you have watched the previous ones before viewing this one. In the last lecture, we started the discussion on the phenomena which could not be explained by the wave nature but by particle nature of the electromagnetic radiations. In that, we discussed about the black body radiation. And now in this lecture, we would continue our discussion further and we would be discussing about the photoelectric effect and how this could not be explained by the Maxwell electromagnetic wave theory, and then how it was explained by Einstein using the Planck's quantum theory. So let us begin today's lecture. So let us see what is photoelectric effect. Photo, light, electric, electricity. So something related to light and electricity is all this effect is about. So H. Hertz in the year 1887, he performed an experiment in which the electrons, they were ejected when certain metals like potassium, rubidium, cesium, they were exposed to a beam of light, right? So electrons, you know, they are responsible for electric current, and this is on exposure to a beam of light, hence photoelectric effect. And the ejected electron is called as photoelectron. So let us see the experimental setup and the experiment. We have an evacuated glass tube. Evacuated means removed all the air with the help of vacuum pump, and we have created now a vacuum inside this glass tube. There is two electrode, the positive one anode and the negative electrode the cathode, and this is connected to a battery, and light is allowed to fall on the cathode. So the light, please do remember, is a monochromatic light, that is of one specific wavelength of frequency. So when light falls on the metal surface, what happens? Metal has free electrons. They are loosely bound to the surface. On receiving light energy, they absorb this energy. Their kinetic energy increases, and this helps them overcome the nuclear forces of attraction, and hence the electrons are ejected. Now the electrons are ejected, they are negatively charged, so the movement is going towards the positively charged anode, and hence the circuit is complete, and hence the electricity produced this way is called as photoelectric current. The ejected electron, photoelectrons, and the phenomenon of the emission of electrons this way is called as the photoelectric effect. Okay, so I hope this is clear. Now let us understand what were the observations of this phenomenon with the help of an analogy. So first listen to what I have to say, and then we will correlate the analogy to the observations of this experiment. So the story says that we have a line of 10 boys, and all the 10 boys, they are equally powerful. Now there is a boy who wants to occupy a position in the line. So how will we able to do that? He will be able to do when he can push at least one of the boys out of the line, right? So this he will attain when he will be successful to push the boy out only when his power or energy is more than the boys of the line, right? So if he has greater energy, then he will be able to push a boy out of the line, acquire his place. The push he is able to give depends upon how much energy he has. The more energy he has, far he is going to push the other boy out of the line. And now he wants that if he gets a position, let his friends also occupy the same position in the line. So he calls his friends. Now these friends also have energy which is equal to this boy's energy. Okay, so these boys, they are going to come and they are going to push the other boys out of the line. If there are going to be two boys, they will push two more boys out of the line. If there are three, then three, and four boys out of the line, right? Now let us understand this with the help of the this example. We will understand the photoelectric effect observations. So let us assume the boy is named to be Rahul, and this Rahul is the incident line of a specific frequency, and energy, you know, is h into nu, the frequency, so that they are directly proportional. So this also has a specific energy. And the line of boys, they are the electrons on the surface of the metal. So the first point says that observation is that the electrons, they are ejected from the metal surface as soon as the beam of light strikes the surface. There is no time lag between the striking of the light beam and the ejection of the electrons from the metal surface. So the moment Rahul pushes the boy, or his friends also come, the moment they push the boys, the boys in the line, they are out. Okay, so the next we have is that the number of electrons ejected is proportional to the intensity or the brightness of light. So if there are three boys pushing the boys out of the line, so three boys are out of the line. If we have four boys, then four boys will be out of the line. Similarly, the intensity, this depends upon the number of photons of the light. So more is the number of photons, more is the number of electrons that is going to be ejected. The next we have is that for each metal there is a characteristic minimum frequency nu naught, which is called as the threshold frequency, below which the photoelectric effect is not observed. So Rahul and his friends, they can only push the boys out of the line when they have some energy that is greater than the energy of the electrons that is binding them to the surface of the metal, right? So we have a light of threshold energy that can break these electrons bonds to the metal surface, and this energy, if it is more than the threshold energy of the metal, so then the electrons are going to be emitted out, and the frequency at which the below which the photoelectric effect is not observed is called as the threshold frequency. So when there is a frequency that is greater than nu naught, the ejected electrons, they come out with a certain kinetic energy. So the push is going to be dependent upon how much energy Rahul and his friends have. The more the energy they have, the more farther they are going to push the boys out of the line. Similarly, the electrons are going to be expelled out with a greater kinetic energy if the frequency and hence the energy of the light is greater than nu naught and the h nu naught. Okay, so the kinetic energy of these electrons is directly proportional to the frequency of the incident light, right? So the electrons, they are ejected from the metal surface as soon as the beam of light strikes. Then the number of electrons ejected is proportional to the intensity, and then there has to be a minimum frequency which is of one metal. So the light should have a frequency greater than this frequency, and the kinetic energy of the ejected electrons is directly proportional to the frequency of the incident light. So what do we infer from the whole experiment is that the kinetic energy of the ejected electron, this is independent of the intensity of light and dependent on the frequency of the light, right? So you can see in the graph also that till the threshold frequency, there was no ejection of the electrons, and after the threshold frequency, the frequency increasing, the kinetic energy of the photoelectrons is increasing. Similarly, if you see the relationship between intensity and the kinetic energy, however high the incident light intensity you are increasing, the kinetic energy of the photoelectron remains constant. Then the photoelectric current is directly proportional to the intensity of the incident light. So intensity of light, number of photons increasing, number of photons increasing, so number of electrons ejected increases, and hence the photoelectric current increases. The no medium is required for the ejection of electrons. It can happen in vacuum as well. So how was the photoelectric effect explained? Well, all the observations which we just now saw, they cannot be explained on the basis of the wave theory. According to the wave theory, the energy of light is proportional to the intensity. So increasing intensity alone, it should have been possible to cause emission of the electron, and also the kinetic energy of the ejected electrons should have been proportional to the intensity of light. But we have seen that increasing intensity alone, there is no emission of electrons, and the energy of the kinetic electrons is also not proportional to the intensity. So who and how explained the photoelectric effect? Who is Einstein? In the year 1905, he explained the photoelectric effect, and he said that when a photon strikes a metal surface, it uses part of the energy equal to the binding energy, that is the energy required to overcome the nuclear forces of attraction. So it uses a part of the energy to eject the electron from the metal atom, and the rest is given to this in the form of kinetic energy. So we have the total energy of the incident radiation equal to binding energy plus kinetic energy of the ejected electron, where now h nu, we know from the Planck's quantum theory, is the energy of the incident radiation, where nu is the frequency, right? So h nu is equal to h nu naught. This is the binding energy. This is also called as work function. So this is also called as work function, where nu naught is the threshold frequency plus the kinetic energy, which is half mv square. Or we can say that half mv square is equal to h into nu minus nu naught. So how are the experimental facts of the photoelectric effect explained on the basis of this equation? So if the frequency of the incident radiation is greater than the threshold frequency, then the energy of the incident radiation is greater than the binding energy. So the excess amount of energy, which is h nu minus h nu naught, this is transferred to the ejected electron as kinetic energy. And higher frequency photons therefore would impart more kinetic energy to the ejected electron, right? So you remember more energy of Rahul and his friends. So that was able to push the boys out of the line farther. Now, if the frequency is less than the threshold frequency, so the energy would be less than the binding energy, so the electron is not ejected. The boys would have not been pushed out of the line had Rahul and his friends having less energy than these boys. Okay, so irrespective of the intensity of the incident radiation. So each photon can eject one electron. One boy can throw out one boy out of the line. Increasing the intensity of the incident radiation of the specific frequency, more number of photons strike the metal, and hence more number of electrons are ejected. Right? But remember that the kinetic energy of the ejected electron remains unchanged. That is dependent upon the frequency. So specific metals, they have fixed value of the work function, and I have a chart for you for a few of them. So the work function per electron volt for lithium is 2.42, sodium is 2.3, potassium is 2.25, magnesium is 3.7, copper 4.8, and silver 4.3. You're not supposed to remember these values. They are basically just to understand the how much energy is required for the photo emission of electrons for these specific metals. So you can see here that potassium work function is the least. So this would be the most easy to cause the photoelectric effect. And now the units here given are electron volt. So do you know what is electron volt? Well, this is also a unit of energy which is equal to work on an electron in accelerating it through a potential difference of 1 volt. Work done on electron in accelerating it through a potential difference of 1 volt. And this is equal to 1.6 into 10 power minus 19 joules. So please do remember this also. It is required for your numericals also. So now let us sum up the whole of the photoelectric effect with the help of one example. So we know that the number of electrons ejected does depend upon the intensity or the brightness of light, but the kinetic energy does not. So how can this be explained with an example? Well, we know that the threshold frequency for potassium metal is 5 into 10 power 14 hertz. So any frequency which is less than this will not cause the photoelectric effect, but any frequency which is greater than this value is going to cause the photoelectric effect. So we have red light with the frequency 4.3 to 4.6 into 10 power 14 hertz of any brightness. It was tried to shine on a piece of potassium metal for hours. But because the frequency was less, irrespective of the intensity, there was no photoelectric effect. No photoelectrons are ejected. But as soon as even a very weak yellow light with a frequency 5.1 to 5.2 into 10 power 14 hertz shines on the potassium metal, the photoelectric effect is observed. Why? Because the frequency has increased. Fine. So this is what is photoelectric effect. And then by increasing the intensity of light of the given frequency should be greater than threshold frequency. So the intensity is going to increase the number of photons striking. So this would be increasing the number of ejected electrons. But because we are using a light of a given frequency, the kinetic energy is going to remain unchanged. Right? Kinetic energy will change when we change the frequency of the light used. So that would be all for this lecture. I hope the whole phenomenon of the photoelectric effect that is clear to you. In the next lecture, we would be discussing about the stopping potential and then some numericals on the photoelectric effect. If you have any problem while understanding the lecture, you want to send us any feedback or any suggestion, you can mail us at h2ochemistry@gmail.com. And if you've liked the lecture, please do click on the like link. Your likes give us an encouragement to work more. And also do subscribe to our channel H2O and click on the bell icon so that you get a notification as and when we put up a new lecture for you, a new course for you. So do click the like link, the subscribe link and the bell icon. Waiting for your likes. Thank you so much. See you again next time. Enjoy your study. Bye bye.